Hey class, in the Unit 8 discussion this week, you'll notice on the screen here that there are 4 parts to it. And part 1 is just mainly asking you to express your understanding of what we mean by normally distributed. So that's just a written response. Part 2, if you were to create a histogram of all GRE scores, what would you expect the histogram to look like? In other words, what shape? Do you think it would be symmetrical? Would it be bell-shaped? How many modes or peaks would you expect to see? Would it be skewed? Like, do you think it would be right skewed or left skewed? Or do you think it would be symmetric? And if you think it would be symmetric, do you think it would be bell-shaped? And explain why. Just, a few sentences or a short paragraph on that one. Then when you get to parts 3 and 4, that's where the parts are going to be more mathematical and calculating probabilities. Be careful about what format it wants, because you see here in part 3 that it's asking to determine the percentage. So of course, once you get your probabilities, you'll want to change them to percentages by moving the decimal point 2 places to the right or multiplying by 100. Same thing here, what percentage, and then in part 4, it looks like also what percentage. So they want percentages in the discussion parts 3 and 4. In your MSL homework, some of the questions may want probabilities, some may want percentages. So be very careful about what format that they ask for, and make sure you're careful about how many decimal places they want you to round to. So I just wanted to take the time to show y'all the difference between parts 3 and 4. And also not only for the discussion, but to be on the lookout for this difference when you're working on your Unit 8 homework. And of course, when you're working on your quiz this week, since you have a quiz that covers Units 7 and 8. So what you have to be on the lookout for with normal distribution problems is whether the directions say to use the empirical rule, which is otherwise known as the 68, 95, 99.7 rule, or whether it does not say to use the rule and it implies to use the z-table. So you want to notice here that part 3 specifically wants you to use the rule. Part 4 specifically wants you to use the table. And while the answers will be close, you'll want to realize that the empirical rule is just a rough approximation, and the z-tables are more precise, which is why you sometimes get slightly different answers depending on which method you use. And that's why you're going to have to be careful when working on your Unit 8 homework and quiz, because if the directions say to use the empirical rule, then you need to use the empirical rule. And if the directions say to use the z-table, or it implies that you use the z-table and z-scores, then you need to use the z-scores and the z-table. Otherwise, your slight differences in rounding and in the two methods might cause you to miss the question just because you're not using the method that they asked for in the question. So really be on the lookout for that. So I'm going to walk you through the empirical rule, and you will also have an empirical rule worksheet provided for you that if you want to let the worksheet do the calculations by hand, you can do that. And for the z-score method using the z-tables, a website will be provided that actually makes the calculations easy for that part. So I'm mainly going to be showing you the calculations. I will also show you the z-table, just in case. Some students like to work things out the long way, just for that's, in their opinion, the better way for them to understand it, and that's fine. You can even work things out the long way and use the worksheet and website to check yourself if you want to. Totally your preference on what you like to do. But the main reason I wanted to make this video is to show y'all how to use the worksheet and the website to do this and to do your homework. Okay, so what we're going to do is part 3 using the empirical rule. And what we need to notice is that it tells us the mean GRE score is 500 and the standard deviation is 75. When you deal with normal distributions this week, the two most important pieces of information that you'll need are the mean and the standard deviation. So we've got a mean of 500, standard deviation of 75. So to do the empirical rule, I'm going to bring up the worksheet. And the worksheet also has a graph on it. So here's what the worksheet looks like, and you'll notice the graph. And when you use the empirical rule, it is always split up into numbers that have 0 in the middle, which is where the mean goes, and then numbers 1, 2, and 3 to the right, positive, and -1, -2, -3 to the left that are negative. And what these numbers are called are z-scores. They are basically telling you how many standard deviation units away from the mean a value is. So if the mean is 500, then that would mean the 500 would be the number in the middle. And of course, y'all could write this in on your paper and stuff that you're doing your work on. And if the standard deviation is 75, then that means you would add 75, take 500 plus 75 and get 575 right here. Add another 75 and get 650, and add another 75 and get 725. And similarly, subtract, take 500 minus 75 would put a 425 here, minus another 75 would put a 350 here, and minus another 75 would put a 275 here. But this worksheet actually does those conversions for you. So you would want to come up here and put the mean in the first box. They told us it was a mean of 500 and a standard deviation of 75. Then you got to go by what the question asked. Now, in your worksheet, or in your discussion, sorry, it asks you, that you can see on your screen right here, to first determine the percentage of students likely to get a score between 350 and 650. Well, because I want you to do that yourself and not already have the answers provided, I'm going to pick two different numbers. So I'm going to say, determine the percentage of students likely to get a score between, say, 425 and 650. So what that means I would do is, in my worksheet, I would have two values. So I would put the lowest value, which is the 425 right here, and the highest value, which is the 650 right here. And then I would press enter. And you'll notice that down here, this program has already converted the 425 to a z-score of -1. That means it would be right here. And you would have already discovered that if you had done it the long way and just taken the 500 in the middle minus the 75. You would have realized that you would have gotten 425 right here, but we can tell that because our z-score is -1. And 650 up here on the higher number has been converted to a z-score of 2. That's because 650 was 2 standard deviation units above the mean. And we would have gotten that by going 500 plus 75 and plus another 75 would have put the 650 right there. So the program already shows us what z-scores they are. And if we did the empirical rule the long way, we would just go between the -1 right here and the +2 right here. And we would add up these three percentages, 34% plus 34% plus 13.5%. And we would get 81.5% that way. But the program has already calculated the probability between those two values. And all you would have to do here is, since the discussion wanted a percentage, you would just have to move the decimal point 2 places and get 81.5% between those two values. So, the worksheet just kind of takes the tediousness of the calculations out of there. But, again, you're welcome to use the calculations, do the calculations by hand if you want to, as long as you develop an understanding of what's going on. And that based on how many standard deviation units away from the mean our values are, so what z-scores they convert to, then we can just use this empirical rule graph and figure out the percentages. Another part to number 3 is to what percentage of students would get a score above 500. And again, I'm going to pick a different number there. So let me go back to the worksheet, and if I only am trying to find above a certain value, then that means here in the chart I only have one value. And actually it should say only one value. I've got to get that changed. So only one value. That means we're going to take out, delete this. And if I wanted to find, say, the percentage above, say, 725, then I would only fill in one number, put in the 725, press enter. And notice it only converts that one number to a z-score, and it would be a z-score of +3, because 725 is 3 standard deviation units above the number 500. Like if you took 500 and added 75 3 times, you would end up at 725. And the worksheet tells you that the percentage above, well, it tells you that the probability above is 0.0015. We can tell that from our graph if we did it the long way, and all we would have to remember to do is convert this to a percentage by moving the decimal 2 places over to the right. So that would make it 0.15%. That is not 15%, it's 0.15%, a very small percentage. And so we actually would say that a score of 725 on the GRE is significantly different from the mean. Anytime you get a value that's more than that's more than 2 standard deviation units, either above or below the mean, then it is significantly different. And the probability would be less than 5%, making it a significantly different value. That is also something to look out for in your discussion this week. You'll get that question. Let me show y'all right here. You'll get the question that says, wants you to use the number 275, so a different number than we used, but it will ask you, do you feel like this score is significantly different from the mean? Why or why not? So get the probability, get the percentage, and if it's less than 5%, a 5% chance that you would get out that far, then you would say, yes, it is significantly different from the mean because it is more than 2 standard deviation units away or less than a 5% chance. All right, so y'all, that is how you do part 3. Either using the worksheet, or if you wanted to just use the graph yourself and take the 500 and just keep adding the 75s or subtracting the 75s and get the numbers yourself and then use the graph percentages to do it, that's fine too. Otherwise, the worksheet will give you those numbers. All right, in part 4, they want you to use the z-table. So a website will be provided for you this week, and the website will take you to this website. It will look like this, and it gives you a visual of everything going on. So kind of similar to the Excel worksheet that we just used for the empirical rule, then we're going to look and see what the problem says. So it says choose any GRE score between 200 and 800. All right. Well, remember, we need the mean and standard deviation. So the mean is still 500, standard deviation still 75. We're using those same values. So I'll go put those in, and I'm just going to pick, say, a score of, I'll use 635, for example. Okay, 635. You choose whatever number you want to between 200 and 800. So I'm going to go back to the website, put the mean of 500, standard deviation of 75, and I'm then wanting to find, let's see what the wording was. All right, using your chosen score. How many standard deviations from the mean is your score? All right, well, that means you're going to have to convert it to a z-score, otherwise known as a z-value or z-score. So I'm just going to show y'all real quick. I mean, I would probably do that on a piece of paper, but I'm going to show y'all real quick. Let me actually just go to my Excel sheet. Okay, so to get a z-score, and let me get to something I can write on here. All right, to get the z-score, if I choose 635, then we actually do 635 minus the mean, and we divide it by the standard deviation. When you put this in the calculator, make sure you do the top first. So 635 minus the mean of 500 is 135. Then divide it by the 75. Make sure you're careful about your order of operations. And I get a z-score of 1.8 or 1.80. I'm only taking 2 decimal places because that's the way the z-tables read, is always 2 decimal places. So what number that this 1.80 is telling me that a GRE score of 635 is 1.8 standard deviation units above average because it's a positive. That's what that number tells us. So in the discussion, when it had asked us how many standard deviations from the mean is your score, then that's all you're going to do is convert it to a z-score. Okay. Then if you want to do this the long way, you would use the table, the z-table that's provided for you, and find out what percent of students would get a score below the value and what percentage of students would get a score above this value. So I'm now going to pull up the z-table. All right, which is right here. Remember, our z-score was 1.8. So I've got to scroll down to the positive. Notice these are positive z-scores here, and these were negative z-scores here. So I'm going to the positive, and I'm going to go find 1.8 right here. And remember, the number in the second decimal place was a 0. So that means I go find a 0 up here. Like if it was 1.83, I would go find this number up top, 1.83. But it was 1.80. So I go here, and I go to the 1.8. And where they meet right here is the number that represents the probability below. So 0.9641 would be the probability below. And if I need to convert it to a percentage, I just move the decimal point. So 96.41% of the GRE scores would be below your score, like if you got a score of 635. And to figure out what percentage above, then let me get back to my sheet. So we got that 1.8 would say that the probability above that, percentage above, is going to be 96.41%. To get the percentage below, all we do is take 100%, which is the total of the whole entire graph, minus what's below, and that'll give us what's above. Anytime you take 100% minus what is below, you'll get the percentage above. And the z-tables always are giving you what's below. So if you have to get above, just subtract your percentage from 100%. Or if you're still in decimal form, just subtract it from the number 1, which is 100%. And if I do this, I get 3.59% would be, oh gosh, and I got these mixed up, sorry. Percent below is always from the z-table. Percent above, you would have to do the 100% minus that. So sorry about that. The z-table always gives you percent below, or really it gives you the probability below, and then you have to move the decimal point to make it a percentage. So the numbers in the body of the z-table, let me go back to clarify since I had the wording mixed up. All right, numbers in the body of the z-table, all of these numbers are probabilities below. In fact, it reminds you up here because it shades to the left. To get above, you'll have to do 1 minus these numbers, or if you've already converted them to percentages, just do 100% minus your number, and you will get what's above. Okay, so this is the correct way to put it. 96.41% of scores are below a score of 635, and only 3.59% of the scores are above that. All right, so now I want to show you how the website would do that. If you prefer to use the website to do your calculations, you would still have to do this z-score calculation to answer the question that said how many standard deviation units away from the mean you are. You will need to do that because the website does not do the z-score conversion for you. But otherwise, we could get these same answers, the 96.41% and the 3.59, if we wanted to just go ahead and use the website, which remember was right here. And so I'm going to go ahead and put in my score, which was a 635. And notice it already gave me it gave me the probability above. It agrees with what we got. We got 3.59%. All you'd have to do here is remember to move your decimal point and get the 3.59%. But when we needed to find below the score of 635, put that in, press enter, and there's our number that we got for the below, 96.41%. So this website just takes the table reading part out of it. If you'd rather something be a little more automatic and not have to go read the tedious table, totally up to you, which you want to use. But you've got this website to do the calculations for you when the directions want you to use the table and z-scores. And you've got this worksheet for the problems that asked you to use the empirical rule, or the 68, 95, 99.7 rule to do that. So for the discussion, make sure you're using different ways to do parts 3 and parts 4. If you use these websites, all you got to do, since you're not going to be able to type in your work because you did it using the worksheet here or the website, all you'd have to do is use your snipping tool, and you could just actually snip a picture of all of this right here so that we could see what numbers you put in and see what your probabilities are. I mean, you still would want to state your probabilities in a sentence in your answer. but this would suffice to do a snip, use your snipping tool, snip, and insert this image so that we can see, oh, okay, that's how you got your answer. Since you're not going to be showing us a formula worked out, we'll see that, okay, that's how you got your answer, and we'll be able to see how you put the numbers into the worksheet. Same thing with the website. If you use the website, you can just take your snipping tool and snip all of this right here, save that image, and then insert that. So once again, we can see how you got your answers. With this one, it would be a little bit harder because you'd actually need to do 2 snips. You'd have to do one with the above percentage and snip that, and then do another snip and show the below. But, you know, like I said, totally up to you. This also does give the visual to show that why there's such a large percentage below that's shaded, and when you do above, it's just this smaller percentage on the right-hand side. So, you know, the visual aid is also good to help you see what exactly it is that you're doing. All right, so just 2, you know, more digital tools to help you. If the number crunching and stuff gets intimidating for you, you can definitely use the Excel worksheet for empirical rule problems and use the website for your Z-score and Z-table problems. So hope that's helpful for you in this unit.